September 3rd, Orange Day, for my geometry drop hour and F. Hopefully, this video finds you well. In this case, again, as you can see, we have self x here. I was talking about this in the first part of the video. This part right here, you can go ahead and write it over here. So you're going to do negative 3 minus 4x plus 2, and then parentheses minus 3x equal to 2, and then parentheses x plus 2 minus 8. So then therefore, what you can do is just kind of scribble that out. Actually, we can go ahead and write it out for you, make it easier. And I don't think I have my whiteouts with me, so just scribble it out. So that way we can just solve our problem. Now our goal is to solve for x cubed. In this case, again, we're going to go ahead and try to get it by itself. So then that way we can just simplify. So in this case, first thing, got parentheses. So we're going to go ahead and distribute 4 to the 1 and negative x, or negative x. So in this case, we have 4 times 1, which gives us 4, minus 4x. And then we're going to keep on rolling. So in this case, notice we're going to have that equal to 8x. And we're going to distribute that 5, or negative 5, I should say. So we're going to have minus 5x, and then minus 10. And now what we're going to do is we're going to go ahead and combine like terms. So in this case, you see the like terms on here. In this case, 4 minus 4x, there's nothing really on that side. But when we rewrite it on the right side, it's going to be 8x minus 5x, which in this case we can combine them because they both have x within them, which gives us 3x minus 10. And now what we're going to do is we're going to go ahead and simplify them. So therefore, I'm going to move each side to 1. I always like to usually keep the x positive because then that way I'm not dividing by negative. So therefore, it makes it a little easier. Add 4x to both sides, you get 7x minus 10 is equal to 4. And then I'm just going to keep rolling. I'm going to add 10 to both sides because we have a negative 10. It's going to be 14 is equal to 7x. Divide by 7 on both sides, x equals the value of 2. All right, so there we go. There's our next answer. So in this case, what we're going to do is we're going to go ahead and solve for question 11 here. So question 11 looks something like this. We're going to take that negative 3, distribute it to both parts. We're going to get positive 12, and negative 3, or excuse me, 12x, pardon me, and then negative 3 times a positive 2, which gives us negative 6, minus 3x equal to 2, and then parentheses, well, in this case, I should just distribute there, so we'll have 2x, and then minus 4, and then a minus 8 on the outside. All right, so as you can see, what we're going to notice is we're going to have those values. So therefore, we're just going to combine all terms again, just like we did. 12x minus 3x gives us 9x. So we're going to have 9x minus 6 is equal to the value of 2x, and then therefore I got negative 8 minus, or negative 4 minus 8, which is going to give me a negative 12. And then I'm just going to put my terms together again. So therefore, I'm going to take that positive 2x, subtract it over. So therefore, I'm going to get 7x. And then I'm going to add a negative 6, so I'm going to add it to both sides. And therefore, I'm going to end up having 7x is equal to, and I should have negative 12 plus 6, which gives me negative 6. And then I just need to simplify. So therefore, what I get is I divide by 7 on both sides, and x equals negative 6 over 7. Now, what you're going to notice here is, again, there's going to be a fraction answer. Get out my calculator here. And I find my values. In this case, negative 6 divided by 7 is going to give you a value, which in this case, it's going to give you a really bad decimal. Now, with that in mind, again, you do not have to write out the decimal because it's irrational, meaning it doesn't end, nor does it repeat. So therefore, you can just leave it as that fraction. They're just simplified form. All right, so hopefully you figured out the solving problem pretty good. Again, this is what a lot of our first chapter is going to be on. We're going to have a quiz actually on order of operations. So again, if you're really good at this, again, you're going to be good for our quiz, which again makes me very, very happy. So the next part, some of you may understand what parallel and perpendicular are. What we're going to do here is we're not going to so much talk about what parallel and perpendicular are. That's going to be coming up on Friday. Friday on because I won't see you on Thursday. What we're going to do is practice putting these values in slope-intercept form, you would remember slope-intercept form looks like this: y equals mx plus b. What it basically is, it's basically just going to drive how much the line rises and runs, and then again where it crosses the y-axis. So again, just to remind yourself, m equals the slope, b is the y-intercept, and then x and y are just coordinates along that line. So that's pretty much the premises of what the formula is. So then therefore again it equals up. Now what we're going to do is we're going to go ahead and transform some of these into slope-intercept form. So in this case, line A, that's already in slope-intercept form. Hopefully you figured out that one's pretty easy. It's not too bad. But again, we'll talk about why it's parallel or perpendicular here coming up on Friday. Line B says 5y is equal to 3x minus 2. So my goal is again get y by itself. So what that means is if I see something being multiplied by 5, I'm going to divide by 5 on both sides. So therefore, when I divide by 5, this cancels, gives me y is equal to, and then I'm going to get 3 over 5x, and then I'm going to get the value of negative 2 over 5, which in this case I can just leave as a fraction, or you can put it as negative 0.4 repeating as a decimal. So there's your value, and then there's your slope-intercept. Now, again, we'll talk about what parallel and perpendicular are, because again, we'll figure out how it goes. And again, it's actually quite easy how you can determine it, and a lot of students do very well with it. All right, and the last one we're going to do is we're going to get y by itself here. So in this case, I got a positive 10. So that means I'm going to move it over. So I'm going to get negative 6y is equal to negative 10x minus 4. And then the same thing, I'm going to go ahead and divide by negative 6 on both sides. So therefore, divide by negative 6. Y is going to equal, well, in this case, if I do a reduced form for it, I'm going to end up getting the value of, which I think you reduce that, I believe it can be, hold on, I think in my head, if I divide by 2, I should get negative 5, or excuse me, positive 5, because in this case, it's going to be two negative values. And I'm going to positive 5 over 3x, because I take out that value, and then I got negative 3, or positive 3, or 2 over 3, I should say, 2/3. And there's my All right, so go ahead and pause this video. See if you can do number 13. Just transform it into y-intercept form. That way, again, you can kind of help yourself out. Again, these things shouldn't hopefully take you too long. Again, they're pretty straightforward, but again, pause this video, then come back and check your answers. All right, so welcome back. This is, again, question 13. I'm not going to go and solve them all for you. In this case, again, most of you should be pretty well adept for solving by now, but in this case, if I'm writing these out, the first one's going to be y is equal to, I had 3 over 4x, then minus 2/3 again. It's one of them. Another one was the value for line B, which in this case is y equals negative 3 over 4x minus 1/4. And last but not least, I got the value of y equals 3 over 4x plus 5. All right, so there you go. Those are the values. Again, as you can see, most of these aren't too bad. It's just, again, getting y by itself and understanding which terms to go along with. All right, and the last one, 14 and 15. So again, most of you, I feel like, are pretty good graphers. Again, you kind of saw a lot in ninth grade, you saw it in 10th grade, and you're going to see a lot of it again, obviously, in geometry, because we have to plot a lot of different coordinates and be able to understand how they can function kind of as a shape or a figure, depending on what we're looking at. So for the next one, it says write a graph, an equation of line that passes through any point and is parallel to the given line. So we're going to, again, skip this part for the parallel line. I'll explain what that is here coming up on Friday. But in this case, we're going to write and graph the equation of line that passes through any given point. So what we're going to do is we're going to go ahead and transform this function. So in this case, what I'm going to go ahead and do is I'm just going to go ahead and worry about just graphing the line. Again, you can cross out that point too, because in this case, we're just going to go ahead and graph the line itself. It's not going to run through that point because, again, that's where the parallel line would be. In this case, again, we're not worried about it. So divide by 2 on both sides. Y is going to equal In this case, I got 2x minus 3 is my simplified form. Now, if you remember how to graph a line, again, we always start with the y-intercept. I think a lot of students struggle with this idea because, again, it's such a simple point, but again, I think overall, a lot of you know how to do this very well. So I'm going to go ahead and put that value at 0, -3, because this, remember, is our y-axis. This is our x, so just make sure you understand that. And then the slope, remember, is rise over run. So if we ever have a whole number like this where it says 2, remember the rise over run, this is actually the rise that we go up. So that's 2 and then over 1. The reason why it's 2 over 1 is because, again, anything written over 1 is just going to be itself, because in this case, 2 divided by 1 gives us 2. So that means, again, I'm going to go up 2 and over 1. And then I'm just going to repeat that same pattern. Up 2 over 1, 2 over 1, 2 over 1, 2 over 1, up 2 over 1. And then again, just all the way back down till you come to the finish line. So then therefore, this is the line. This is what it looks like. Okay. So as you can see, again, the line looks something like that. Now, some of you again are asked, well, again, was asked to do parallel. Again, we do not have to worry about it. Now, some of you are probably going to figure out parallel actually means, again, it's not going to ever intersect. And again, we'll talk about that, what it means for slope coming up on Friday. All right, and 15, the last one. In this case, again, you do not actually have to transform this one. This one's actually given to you already. So in this case, you can go ahead and cross out perpendicular, and you cross out the points. What you're going to do is you're just going to go ahead and solve for the function. So therefore, y equals 3 over 4 over 3x plus 6. So we're going to do our rise and run. This one is going to be positive 6. So we're going to go 1, 2, 3, 4, 5, 6. And then remember the slope is up 4 over 3. So I go up 1, 2, 3, 4, and over 3. Now some of you are like, well, what about the backwards? Well, in this case, you're just going to go opposite. So therefore, what you're going to do is you're going to count down 4. 1, 2, 3, 4, and then over 3. And then down 1, 2, 3, 4, over 3. And then just keep that pattern going all the way to the end. And you can graph your function will look something like that. So as you can see, again, there's our two lines. Remember, the positive and negative slopes, a lot of students struggle with this too. Positive slope is always going to go up the hill. So in this case, always think about your inclining or going up. If it's negative, so again, there's a little negative sign out in front there, and then you're always going to slide down the hill, so you're going to go down it. Again, students seem to struggle with that a lot too, especially when we start graphing for the perpendicular and parallel lines. All right, so this is part 2 of the video for geometry. Hopefully you figured out that A-okay. Again, the instructor, whoever's subbing for me, should be able to hand out, again, the different functions. So what you should have in your possession now is you should have the toolkit with your name on the inside corner. And that should be on page, I think page 1 or 2. We'll go through those together kind of as a class. You should have homework packets. Again, the homework packet is everything that we have in terms of homework that we'll have for chapter 1. So again, you'll be able to see your first homework assignment, which is section 1.1. And then the last one in this case, again, is going to be the student guide that tells us everything from our quiz to our test and when everything is for the first chapter. So with that in mind, have a great rest of your day. Again, you feel free to work on the homework, get that done. Make sure you're being good for the summer. Thank you so much. Have a good day.